Okay, so welcome everyone to our second Grasshopper basic courses. So in our last courses, we mentioned about some setting, basic setting, some operation, some component types, and some uh, data management methods for in the Grasshopper. And before I start about today courses, I try to ask myself if I'm new to the Grasshopper, what will I like to learn at first? So I really want to learn something which is could be easily or um, much more faster realized in the Grasshopper, but it's really hard or complicated to do that in the Rhino. Also, I also want to learn something which is I will frequently use in my daily job. So this three function methods of the gradients, random, and attractors. These three um, script logic come to my mind at first. So before we start learning of this, let's just using a very simple example script to familiar with most of the component and also understand the general workflow of the Grasshopper. So we could see that they have bunch of components, the parameters, mass, set, vector, curve, surface mesh, and after the displays, those part are all the plugins we in, installed by ourselves. So the parameters, we usually use the geometry part, like we use the step of curve to link it with the geometry we have in the Rhino. And we also use the input part, like the slider, we enter a number like 10. So after we have a curve, so we are going to, how about we try to divide the curve, and we could see that in the divided curve component, we get the input of the curve. So we link it with the curve, and they have how many points you want to divide it. We link a number to the count, and now we get multiple numbers, and we could control it by different the slider we want, the number we want, and now we have output of the point at first, so we could output it with the point and link it. So we get multiple point. And usually we want to check each point. We use the set. There have multiple component for the list. We use the list item and we link all of the point in the list to the list at first. And we give an index number, like we have 18, 19. So after we click this list item, this this point will be highlighted. So if we move it, we could see that they just select each point in the index. And after that, we also see that they have a tangent vector output. But what is vector means in the Grasshopper? So usually, let's see, where is it? Yeah, we know that vector is meanings a direction plus the length. So what is the default setting of the vector of a point? Like we have this point. We use the displays of this vector displays. We give it an crow, like we give this point to the crow, and we also want to see the vector. So we enter the vector, we link it, we get a vector and enter there. So now we see a vector of those points. But what does it mean? Why it's shooting on this direction? So maybe we could also try to enter another one, XYZ. We got an original point. No, maybe not this one, XYZ. And vector XYZ. Okay, now this is the original point. We copy another vector displays. Okay, so now we could say that the direction of this vector is default setting from the original point to that point. So and the same length of it. So we could see that there also have, let's try to link it with all of the point. So all of the vector of those point shows like this, but they do have another output is tangent vectors. So we want to see what it looks like. We just link it with the vectors. So here it is. So it follows the curve and the tangent direction of the curve based on each point. So now we know we have all the point which we divided on the curve, and what we do next, we usually we give based on those kind of points, we give them as the circle center of those points. We give those points as the center of the circle, and we give them a radius like 11. Okay. So now we see multiple circle, which is parallel with the world panel. And how about we use this normal vector linked with the tangent vector? So now all of the circle is follow the direction of the tangent vector. So if we give them a lot, so it will shows like a very normal tube we usually see. So now I'm not satisfied with that. I also want to change the radius. I want to make it in the different kind of shape like this we have. So what should I do next? We notice that there also have another output is parameters. So let's see what it looks like. It looks like a point from a number from 0 to 1 in the range of 0 to 1, and there have multiple weird numbers over there. So those kind of points usually in the 3 dimension, we know that if we want to locate it a point, we could use the x, y, z value to locate it. Also, if this point is on the surface, we could use the u value and the v value to locate it. But if a point is on a curve, we could use parameters like if we got parameter of 1 or 0, it will be at the end of the point. If it is 0.5, it could be in the middle of the curve. So the parameters meaning means where is those kind of points located on this curve. So how could we use that? Now we have the input number like from 0 to 1. That is quite familiar because we usually use that for the graph mapper. Is using the function with input of the 0 to 1 and output with the function of the y value. So if I link it this to the input, and I will get the output of the y value like this. So I could control the y value with different function in the graph mapper. So let's just, right now it's too small for 0 to 1, so I use multiple. To make it a little bit bigger. And I link it with the radius. So now I could control the outside of it. Also, I could change another type of the function in the graph mapper, like this one. So I could, if I increase this, so I could control, make it moving around and change to the different kinds of shape I want. That's so weird. Okay, so now we know that is very frequently used to use from the 0 to 1 parameters input to the graph mapper and output for the y value to control a bunch of data. So how about if we have a group of number which is really big? So that's what we will learning today, is to use those part of the domain. So we usually use the remap numbers to remap those kind of data into the range, specific range from 0 to 1. So we link it with to the value, and then now we need the range of those part of the data. We used bounds to get what is the smallest number and the biggest number in this list. Okay, is 145 and 843. So we link it with the source, and we also need a target. The target is the domain from 0 to 1. So we give them a star number from 0 and n number to 1 and link it with target. So let's see what we have now. Okay, so we have all the number remap into from 0 to 1, the smallest to the 0, the biggest to the 1, and all is in the specific location where they are, like in a part of the curve. They have different number of it. And after that, actually those part of logic will be frequently used in whether the gradient or random or attractor we will telling later. So let's just see something about the random at first. So when it comes to random, we generally have two different kinds of method. First one is, let's just copy this one. So we get a range from 0 to 1. The most frequently used is the random component. We give them a range and we select how many numbers, like 10. We want finding or export from this range, and we give them a seed which could get the different option output from the random. So that ways is to randomly generating the data in the specific range. But how about if we already have those kind of data? We just want to mess up of the order. So we will use this Jolter. Okay. So we link it with the list. And we also create another.
I had a question.
Yeah.
What is the seed doing?
Yeah, the seed is like, you could understand it as different options, because like I change the seed, you could use any numbers to enter of it, and after you change the seed, it will change to another option of the result. So it's like I randomly pick another option. So the seed is a control of the random option of the final result. Yeah, like if, let's see, the jitter also have the seed. So if we copy this, now we got the same number of the output, but in the different order of it. So like, see, we have the 0.11 and 0.11 is on the second. So if we change this, it just changed the order of it.
The order,
but,
okay.
Yeah, okay. And the seed for the random is to changing different selection. So And they do have other ways to do that. It's like we could use random reduce. Do we have over there? Yeah, random reduce. Like we give the list of it, and we give like I want randomly reduce 5 number, and now I could get random reduce 5 number or 4 or 6. And if I change the seed, it will random reduce different ones. And also we could also use the random split list. It's like same logic. It's randomly split this list into 2 different lists.
Okay, I got it.
Yeah. That's the stuff. Those kind of components is what we mainly use for the random. And remember the stuff we have learning there for remap all the bunch of data into the specific range from 0 to 1. Okay, so let's start to, let's hide this. Let's create something interesting, like I want to create a big panel which have many circle on it, and but the circle is gradually or gradiently from right side to the left side. So let's see, we could start with the square to create the panel, and we give them like a size of 4, and we multiply it with like 50. So now I have a very big panel which is divided by multiple square. So I also want to get outline of it. I calculated what is the length and width of it. I used the rectangular to get outline of it. So now I get outline of this multiple square facade, and I also got all of the square in the middle. So I also want to have the center of it. So I use the polygon center. I will get all of the center point of each square. Let's hide this. So if I just use the circle we did before, we enter the center to the circle and we hide the center number of it. So now I have a bunch of circle on a panel. So what should we do if we want to randomly pick each of the circle and let it gradiently change from one side to another side? Let's just copy some script we did before. So we know that we will use random, and random, we will give them a range. Like how about we just use this range from 0 to 1, and we give it how many numbers. The numbers will be the total number of the circle, so we will use the length, list length, so of this. So this will be, yeah, this will be in the group, so let's flatten it. Okay, now we have 2,500 circle of it. We give them the number, and now we will get multiple 2,500 different numbers in the range of the from 0 to 1. And we link the center number to, so we want it gradually change from the right side to left side. What do we really care about? We care about this, the center point is their x value of it. So we will get the x value of the center point, x, y, z. Okay. vector construction. The construction. We'll link it over there, and we like to get x value of it. So we link the x value to the value of the remap, also the bounds of it. Yeah, so all of the x value of those points is from 2 to almost 198. So we remap it. Now is from 0 to 1. So what should we do next? We will do some magic stuff is to compare it. Compare this two part of the result. So it will output choose and force, like whether those point is bigger than another one. So we get bunch of choose and force, and we are going to use this part. This part, this patch. Okay, so it will add all of the point into the list and use those kind of choose and force as a dispatch pattern. So I will get result like all the choose number will into the list A and all the force number will into the list B. So let's hide this, and link the list A to the center. Awesome. So now we could see that we have this one. Oh, we could also add a graph mapper in the middle to control it. Like we change it to this. So now we could control where it is or how does it gradient change, or we could also change it to another function like this. If we move it, it will follow this to change. Also like this, or like just normal stuff. So but I know it's a little bit hard to understand why it looks like this, why it randomly picked those kind of point to as the center of the circle. So let's screenshot of this page over there, where it is. Okay. So now we know that we have the number of the random, our random number for all those points is in the range from 0 to 1. And for the x value, original x value is from 2 to 198. And we remap those kind of value in the range, also in the range of the 0 to 1. So now we have all of those points. The x value is 0 to 1. So what did we really compare? We using this larger than what we compare over there. Is that the random value with the x value? No, actually we are compare is the probability of the x value, whether the x value is bigger than the random value. Random. Okay. So how about let's see this line. All of point in this line, the x value should be 1, of course. So the percentage of the x value in this line will be 100% bigger than the random, because whatever the random is, this line should be bigger or equal to the random value. And for this line, the x value is 0, so the percentage or the probability of the x value bigger than the random value should be 0%. So after we sing that, like we see the it's not whether the x value is bigger than the random value on this map, we are looking for is what is the probability. So it will randomly pick up those kind of number is just because when the x of the circle is larger and the probability of the x value will be greater than the random number is greater. Yeah, so that will be the main idea for why we use the larger than, and we use the result of the true and false and use the dispatch to output the result to showing that gradient change of this panel hole. Okay, so but we also want to do something different. Is like I don't want those kind of circle layout as very horizontal and vertical. I want it like randomly showing on this panel. We could use another script like this. So we will use this component called populated 2D. And also there have populated 3Ds, populated geometry. We could just randomly generate some point in a 2D or 3D or box or different kinds of scale. So this one, we will randomly get bunch of points in this area. Also, we should notice that if we just link the scale to the region of the populate 2D, it will a little bit out of range. So we usually use the offset of the curve, make it a little bit inside of it. So right now it will be perfect match with the original size of it. And after that, we use the same logic of we remap the whole number of the y point, and we could also change to the x point. It will change to another side. Um, and if we change the random seed, it will random pick another option of it. And we could also change the where we want those circles centralized on, or what it looks like in another stuff like this. We could also move it on one side, another side. And here we use another is co-pattern, which is really similar to the dispatch, but dispatch is they split the true and false into two different lists. Like list A is for true result, list B is for the false result. But the core pattern is only keep the true value. So we only have one output for this. Okay, so this is for random stuff. So what we also have learned before is the jitter. Jitter is something, this is a script I did before. It's like sometimes like the supplier or the factors, they give us some limitations, like they told us we only have several different kinds of facade in specific lengths, like we have 3 different facade in the length of the these 3 numbers and in the width of these 3 numbers. So we already have the certain type of those kind of panels we want, but we still won't have a random result or output. So now we could use the jitter. So if we duplicated those part of the data, it will repeat it in the certain way, but after we use the jitter to mess up the order, so it will randomly looks like this. So if we change the seed, it will randomly change the result of it. Also for the height of it, the length of the panel. So after this, we could get an extrude bucket. So let's hide this. Yeah. Now we will get multiple panels in the specific number of lengths and widths. So that could be quite useful if we want to doing some specific design for based on their requirements. Okay, let's delete this. And another stuff we are looking for is like this part of script is for the break wall. So we use the idea of the random split list over there. So it will random split the list, those kind of bricks into two parts of the one is the white one and the gray one. So it has same idea. If we change this, it will change the way to control where those kind of break will lay out or yeah. And after that, I also use another part of the script, same idea with the remap stuff, and we move it those center point a little bit with on the y direction. So this way we could see that there have many break they um, extend out a little bit. Just is based on those part of the script. Since we already have the center number of those kind of breaks, so we use the jolter. This is what we have learned before, that if we already have the list, we want to make it looks like randomly, we use the jolter and we output it like extruded and showing the color of it. So that is meaning what we have for the random. And for the attractor, let's show you guys a very simple example of this. So attractor usually just means all of the geometry will be influenced by a point or by multiple point or a curve on those around the surface. So I created this like bunch of the hexagon of this, and we could see that we use the center point of this to create a circle, and I want all of the circle or the surface of the circle is facing to that point. So I will use, if I see it clearly, I could use vector displace with anchor of this, and we will see the vector, all of those surface center point is facing to that point. So if I move this point to other side, the vector is follow it change. So if I delete this, let's move it again. So it will looking like this. It will changing following this point location. So if we adding multiple point into it, it will showing like different kinds ways like this. And I also did something fun before is down. Okay. It's like using the multiple mirrors materials of the surface to reflect the sunset, uh, reflect the sun directions. It will showing to some words in the finals. So that's some fun script we could do based on this logic. Also, there have some other stuff for very important script is this component called pour point. It's like it will tell us where is the what is the distance between all of those points and to the center point of it. So let's see an example of this. This is a project, this landscape project showing over there, like they have a tree in the middle and all of the floor um tell tellers tiles, floor tiles will looks like squeeze aside a little bit because of this tree, and it will give us the effect of the visual expansion. So how could we doing that? Let's see in the grasshopper where it is. Okay, hide this. So first we draw an surface of a rectangular, and we divided those kind of surface into multiple square. So now we have bunch of square on the surface, and we give them use same idea of the populate geometry. We give them a range, and all the populated geometry we give them, we could change the point on it, and we could change the where it is or how far it is, the scale of it. So let's maybe just use 5. After that, the very important stuff we need to use is this PowerPoint. So we will calculate all of each center point of the square, how far it is to the center point, to the populated geometry. So it will give us the distance of each point. Yeah, so now we will remap it to the 0 to 1 at first. Let's change it to 0 to 1 at first. Okay, they have some arrows like cannot scale with the factor 0. Okay, we could just change it a little bit to 0. Now let's hide those stuff and see only this one. Awesome. So now we know that scale is like using a factor to resize a geometry. So now we use the distance to resize those kind of square. Like if the distance is really big, it will be the normal size, but it's closer to the center point, it will change the size of it to smaller, or we could also change it a little bit of this or of this, or if we change a function, like we change it, yeah, also we could change how it looks like of the gradients way. Wait, wait, okay. And if those two change different, we could also make it as like this. But now all of the square is with the straight outline. I don't want it to be like this kind of standard because it didn't looks like the effect of visual expansion. So I could also added those kind of add a force. It's hard to say. Let's hide this. Okay. Hide this. Okay. Let's add an like charger to those points. We add an force field to each of those points. So we could see that with like the vectors, it looks like this. It's shooting out from the center point to the outside, and we use the polyline redraw of the new outline of it. So hide this, and we showing the final result. And if we had that and hide this, yeah, now the outline of it changed a little bit. So we could also use this to control it. So make it looks more likely what we have. Okay, so now it's not the straight line for the floor tails around the tree. So that's some way we could do that with those kind of functions. And how about if I don't want to do that on the floor, I want doing that on a facade, or I also want to make it with multiple factors or multiple attractors in the middle. We could use those kind of script. Okay. In this script, we use 2 point to populate it to the point over there. Of course, we could do multiple to showing the influence on this facade. At first, we get all of the points of on this facade, and we try to use the pole point to link what is the distance between those kind of points to the center point. And we remap the distance to make it as a function like this. So it will give us like a wave or ripple effect like this. And we created the facade. We move those kind of points based on this function, and we will have the facade looks like this, and we use this counter to cut the facade, and we will get the thin facade at the end. Let's hide this. Hide. Okay. Yeah. The thin facade, like each panel, which will be showing it like this. And after that, so now we already know we could influence it by the point. How about I want to make it influenced by the curve? Like if I created a facade like this and I draw a curve, and I will link it to that curve, set one curve, and same idea. We use input that curve into the geometry of the pole point. Okay, so it will give us the distance of all of the geometry to that curve. So it, and we remap it and resize of the scale of it. And also, if we want to change the what it looks like, we could change the domain of it. Like we change it to offset way, so it will look like this. And if we change it this to be bigger or smaller, it will keep changing with your different input of the parameters. And output, we use original outline and resizing outline to create the surface we want. So this kind of script will be meaning showing the result, like those kind of rendering views like this. Okay, that's many script we did for today. Also, I attached several interesting script over there which use the same logic of this, like this one, and also the one another way, the straight line for the landscape. Also, we use some attractor idea, and also like this. So if you are interested, you could just follow the video and created your script step by step, and you will learning multiple stuff doing those kind of workflow. Yeah. I think that's many for today. And guys, have any questions?
I wonder, at PAX, do we have a library with scripts like this for previous projects? So we can have a reservoir for.
We have a library, Grasshopper. The Grasshopper library should be, let me find where it is. I think it's in the S drive. I also created Grasshopper script, Grasshopper. Okay. I also created a checklist. So which one is the most, this one. So I input most of the script in it and the file location of it. So it combined with multiple script we did before, and some of it have some tutorial link and some notes and where or which project did we use it, or where is the folder path, and most of them is good to go. So you could just copy it and just use it on your side. And I think this is mainly for the Grasshopper script location. So let me just copy this, maybe this one. File path. Also, by the way, we do have the script for the Dynamo stuff, and I think is in P drive script or Rapid Dynamo. No, not this one. I know. I don't remember where it is. Let me check. I remember I have posted something about the checklist. Grasshopper database checklist. Okay. Okay, another file path is Dynamo, Revit Dynamo. Okay, let me copy this over there. So the Dynamo, there have many errors and buggings for it because the script is mainly provided by the MyBeam team. So, but there have much more database you could use for Revit Dynamo. MyBeam team. Yeah, there have multiple stuff. You could, if you have any requirements, you could generally see what it will be, what those kind of script used for, and to see whether it needs debugging, or if you need any, like if you want to create your own script for your project and you got some issue with it, you could just contact with me and I could help you to doing that. That's it. Any other question? Script. Okay. Awesome.
Sorry, I have a question.
Yeah, sure.
Is this recorded, and two is will the scripts for this be available?
For those
For the
kind of
stuff that we did today.
Okay, of course. I could copy the script to, I think several of them is in the database, but I could also save the script in somewhere in the S drive or somewhere. Yeah. I will attach the link in the chat box. And the recording, I will, maybe next Monday, I will publish that recording on the iSthread. Yeah.
Okay, thank you.